Good afternoon. Welcome to the sort of the part 2 of velocity. MK covered the first part. For those people who were not here, we went through actually introducing what the velocity is and showed lots of demos. But what I'm going to really do is go through, sort of under the hood, more go through mechanisms as well as some of the architecture and then some of the design decisions that we took, why we did what we did. Let me introduce myself. My name is Anil Nori. I'm a distinguished engineer in the SQL Server group. You guys might wonder what SQL Server is doing with data caching, but the application caching. But I think I have actually a slide which shows that I believe apps are becoming more data-centric, so it makes more sense actually to bring some of the mechanisms into the app space. So that's one of the motivations of actually building the cache. My background is a lot of database background and also build a lot of apps, the composite apps and middle tier apps. So I have an appreciation for actually what it takes to really make apps faster and then scale. So those are some of the motivations. In terms of the really outline, I'll go through a recap. There's one slide that MK put, so I want to just go through for those people who are not here. Just quickly really introduce the concepts and then go through velocity vision. Just step back and then look at, what is the bigger picture of velocity? Yes, it is a cache, but it's more than a cache in some ways. What is that? And go through velocity in action. What I mean by that, take the key operations like put and get operations and then walk through the flow, so how it goes all the way from your app to the cache service and then, how does it come back? What happens in between? What messages go back and forth? So that's what we look at. From that, it actually gives you a good idea of really good, provides foundation for what should be actually the system architecture look like. And then, so I'll spend some time on the system architecture, talk a little bit about futures. We have actually some of the demos that MK shouldn't show. He could not show that I have them. If we have time, actually, I'll ask him to come here and then show those demos also. So we'll see. I'm being very ambitious with given the content that I have. So the recap, it's an explicit cache, and then we stress that explicit. Sometimes people think that it's a transparent, like a file system cache or a database cache that automatically you touch the database and then things are coming into the cache. No, that is not it. It is actually an explicit cache where you do put actually objects into the cache. And as MK pointed out, the fundamental thing is it takes actually a bunch of machines with its resources, memory, CPU, everything, and then stitches them into a transparent global cache view and unified cache view. From the application perspective, you have a cache name, and then you have some way to connect to that cache, and then you're actually operating on it. Initially, it will be just simple put and gets. Over time, we'll actually provide more and more data services. So that's sort of at a high level, what the cache is. And in terms of really why we are doing it, MK pointed out some of the benefits of why we are doing it. I wanted to really provide actually a broader picture of what the motivations for these things. Some of you might have gone to Bob Muglia's, the keynote, demos and then the talk. He talked about the data platform. So in many ways, actually, there's an applications, and then as actually the applications are dealing more and more with data, you need to really provide a bunch of data services in all tiers, not just only the backend database tier, in the middle tier and in the client tiers, in all tiers. And we call that data platform. It's not necessarily a database system. It is a data platform which provides a lot of data management and then data access capabilities. You want to run link queries. You may want to run analytics on it. You want to run actually reporting on it. So it provides actually data platform. As part of the data platform, we believe that having a data in memory and then providing all those capabilities becoming more and more important. That's because to enable the next generation distributed apps, more and more applications are becoming data-centric and then event-driven. What I mean by that is, 5-10 years ago, even actually today, most of the apps are very process-centric. So you have actually, a business process which actually has very rigid processes that go between, different components of the application. But as soon as you really deploy those things, components actually in a large-scale distributed systems, that really very rigid handshake becomes very difficult. You cannot scale. Performance and then scale and availability become a big issue. In a data-centric approach, it's more state-driven, so where sort of independently make a change in the state, but the other parts of the application actually get notified and then they can react to that. So it's more, events happen, you make changes to the data, events happen, and then events get notified to actually pieces of the application, and application actually works. So that's what I call actually data-centric event-driven app. And the data can come from anywhere. It's these application pieces, and then the data can be in any tier. Therefore, you need to provide data processing capabilities in all tiers. And more important thing is more and more data, big apps will be for performance and then for availability, as well as scale reasons. They're building more and more distributed, loosely coupled manner. Yeah. And all of most applications, whether they're web applications or enterprise applications, the demand for actually increased scale is becoming important. And then finally, as really we move to software plus service orientation, like this conference, most of the emphasis has been on the services aspect. And as you start really putting your apps actually in the cloud, guess what? People do want actually very large scale and also availability of the apps, and then performance, the latency, all of those issues will become more and more important. So we think that actually caching is very relevant actually in the bigger picture of what Microsoft is doing in terms of the data platform and the services and software and services strategy. So that's sort of really the backdrop of why this project, and then why is it important actually for Microsoft. So in terms of the velocity vision, initially we took a lot of the web scenarios, and this requires most of the times I need some kind low latency access, and I need high scale and availability. And if you look at lots of the data in the web scenarios, tend to be mostly read data. There's a lot of read data, and I can cache those things, and it's a low-hanging fruit. I can provide high performance for those things. And also you have activity data that, as MK pointed out, like your session data in your ASP.NET session state. Those are some examples of the shopping cart, and those you want to scale out. That's the low-hanging fruit scenarios for us. And as you move towards much more richer scenarios, you go into the enterprise and then high performance computing scenarios. There is more computations are required. I want to really run queries on it. I want more sophisticated data access to those things. Right now, all the demos that we showed had mostly key-based access. You can put an object, you can get an object, but can I actually write more complex predicates? Can I actually run link queries on those things? Can I co-locate computation actually close to the data? You have the cache tier, and then you have app logic, business logic is running in some other tier. But sometimes, for performance reasons, you want to really put your business logic close to the data. Very similar to what you do with stored procs, in databases. So we need to really enable those things, and especially, some of the application sectors in financials and telecom, it becomes very critical. They want sub-millisecond access for a lot of the operations that they do, and in order to support those things, you need to co-locate computation also. And while everything is in a cache, still, people often are saying that, hey, can I persist my cache? Can I actually do some? I don't want to lose my trade data that I actually put it into the cache. I use the cache for performance reasons, but I don't want to lose it. Eventually, not only availability purposes, for a long term, I need to keep it. Whether it's for non-repudiation or whatever it is, I need to log it. So how can I push actually things out of my cache into some backend store? So that's what actually I call it persistence. And finally, in the enterprise scenarios, there is heterogeneity exists, and then what if I have actually I have a portion of my application actually is in Java. Can I actually have Java client or PHP client or a C++ client, C# client? So we do think that providing heterogeneous client support is very important. And finally, we look at software plus services. So that is the area where I just mentioned. Can I put actually the application cache in the cloud itself? Integration with SSDS and Windows Azure. Those are the two things that we will be looking at. In fact, we are already looking at those things. And another important aspect of it is, providing more data services, in the cloud itself, like how do I provide self-service BI, and Microsoft has talked about, in some other conferences about self-service BI. Now, can it integrate with actually the data that is in the cache? Can I do streaming, processing, on those things? Can I do reporting? So we want to really integrate those things, along with the cache. So it shows the sort of the direction, in which we are going. It's not a release, map. It's not V1, V2. We have some features from the web scenario and an enterprise scenario already in V1, and then some of them will come in V2s or beyond that. So it's not really a release roadmap, but it is actually where the technology that we want to take it. So let's look at actually velocity in action. What I mean by that is let's look at actually they take a configuration and then let's look at how the operations actually flow through the velocity system itself. And I'll take the same configuration that MK has put it before, so it's familiar. Let's take actually 3 cache servers. It's a cache service, and there is a client tier, and that's where actually your application is running, and there is a cache tier. And in the cache tier itself, so you have actually the velocity nodes, and we'll talk about here 3 things that we talked about is data manager, object manager. We'll talk about that more in detail. And then there's an availability substrate that provides actually high availability. And then there is a cluster management support. Again, we'll go into those things in detail. So just keep this in mind. And let's look at some of the caching scenarios, caching configurations. So MK talked about 3 different types of data. He talked about reference data, activity data, and then resource data. If you look at reference data, it's the easiest way to really build a cache and then provide scale is to replicate the data in the cache. If you have multiple boxes and if you have a memory available actually on each of these boxes, the easy way to do that is go and replicate actually data all your boxes, and then redirect actually your traffic to those boxes so that you can actually get scale and performance. And it works really well when you have mostly read data, and that's what actually this the sequence is. And I have 3 caches, and I have already some data items there, and then now I put actually a new data, and you put a data, and there is something called a routing table, and which actually directs actually your request to one of the nodes. And why that one of the node is the reason is that we have a notion of a primary. Every data item in the system is mastered by some node that becomes the primary. It's like the home base. There could be multiple copies of this elsewhere, but there's one place where there is a home base. Currently, all the write requests actually do go to that home base. We could potentially go for the reads, you can go to different places, but writes do go there because we are still striving to really provide, sort of consistency. Again, I have, the later on, I have 4 points that I bring up. There's performance, scale, consistency, and then, availability. There's a tension between, these things. If you want high availability, you may want to give up some consistency. So I'll get to that. But there is, just for this slide, just remember there's a primary. The routing table knows that, that I need to really send this request to the primary. I have a slide which tells you how does the routing table know that, where the primary is. So in this case, the routing table says, put this thing, in cache 2 node, and then sends the request, and then it gets actually pushed into a replication queue, and we actually log the operations there, and then it actually puts the data locally, and then returns control back. In this case, actually what it is doing is it is asynchronously propagating the updates to other places. So it's sort of a weaker form of replication where, because if right now actually if this node dies, you could potentially actually lose the data. If you wanted actually something immediately, then you would actually synchronously send the messages. In this case, asynchronously sends the data to the other nodes. And then when a get comes, request come, it can actually go to any node and then read it. So we both asynchronous and asynchronous typically gives weaker forms of consistency, and if you really want stricter forms, so you do it synchronously. So that's sort of the really simpler form of really building a cache. It does give me read scale, but if I really have lots and lots of really activity data, which actually I need to do read writes, this configuration is not good because if I have to replicate every time, then it is expensive. And then also, if there is lots and lots of data, it's very difficult to really put that same data everywhere. So that's where the notion of a partition cache is important. So MK talked about the partition cache, so I want to really go into the sequence of these things. Now think of really, again, the same nodes, but the data is partitioned here. You have K1 V1, which is the primary is actually cache 1. K3 V3 is already exists, that is cache 3. Now K2 V2 is actually put there. Again, the routing table says, the primary for this, based on some hashing scheme, which I'll talk about that. It actually puts it, in this node now. And once that is done, once it is put there, actually you can return back. I'll just hold back, so I'll tell you, what that blob is. But then actually you get the return back, request back. And a get request comes, and then again the routing table appropriately routes it, and then the request comes back. Now what I've done actually, putting it actually into the queue, the boxes are actually is a queue, is by putting these things there, in future, if you really want to really do notifications, we'll come to the notification scheme where if some client wants to be notified whenever a data item changes. We keep actually all of these operations in a queue, and then there is a logical sequence number that we arrange actually for all of these operations. So if a client actually knows, it knows actually how far it has seen the changes. So whenever it actually wants to poll for the notifications, it sends that LSN and then says, tell me if anything has changed since then. And then the queue, from the primary, the queue, we can send back all the changes. So it's an efficient way to really implement actually cache notifications. So I have a slide on that. So that's why I put it there just to really provide the context here. Now let's look at actually the routing table. I mentioned in a routing table a couple of times. So what is that? Routing table actually is a subset of the partition map, which actually MK talked about it. Basically, all the data items, we take the key and then we hash it, and then we actually take the hash IDs and then we map it into partitions, the key ranges. And because based on the partitions, once you partition it into several partitions, we take those partitions and then spread them onto different machines. That's a way to really load balance and actually do the data placement across the cluster. And what routing table tells you is that given a key, it finds out saying that what partition is it in and what node is it in. That's fundamentally it. And we can actually incrementally build it because it is on the client side. How did it come to the client side? The very first time, a client may not find it. It goes to some server, and then gets it, and then it starts incrementally populating the local routing tables. Think of really like how you do the names are DNS names. How they build it. Over time, all the clients will have actually information about what object lives where. It could become obsolete, but then again incrementally they get refreshed. And in addition to keeping it only on the client, the servers also keep the routing tables, because sometimes in Velocity both clients as well as the servers both can actually route requests. So let's look at actually the key mapping slide what I just talked about. MK mentioned about we have the notion of items as well as regions. Fundamentally we take the keys, whether it is actually region or whether it is an item. If it is an item, we actually create a default region and then we put it into the default region, and those regions actually get hashed into certain IDs. And now you take all the ID space and then partition it. So you now have a ID 0 to 100 is partition 1, and then so you just put the partition table, and then each of these partitions are actually mapped to a different cache service. So as long as you have the partition information available in all these nodes, they can actually route the requests. That's pretty much it. And I'll actually use this concept later on, so just keep it in mind. And there is two types of these partition maps. There's a global and a local one. And the partitions, the local partition is something that is on its node. It knows only the partitions that are local to that node. A global partition map knows about all the partitions that are in the cluster. So now let's look at, in addition to the partition cache, let's look at the local cache. MK talked about the local cache for performance reasons. How does that work? Basically, you put an object like the partition cache. The routing table sends it to the right place, and then the data comes back. Now some other client wants it, so it gets it. It doesn't find it locally, so it sends the request to actually to the cache to write cache service. It brings it back. Now this time actually locally caches it. So once it is local, it's available there, then the subsequent request, then it really doesn't have to go back. It actually just pulls it from the local cache and then gives it back. And this actually can give you orders of magnitude performance over actually going to the cache service. Remember, when you go to the cache service, you have not only you are actually going across the box or across the processor or the box, you are incurring some serialization overhead in all of those things. In local caches, we keep them actually in the deserialized object form. So you can get considerable performance boost. But it also means that somehow I need to now keep the data that is actually the primary data as well as the local caches in sync some fashion. And that's what the notification mechanism will help. So I have a few slides to show that. So local cache can help speed up the performance, and notification mechanism is required to keep these changes up to date. Let's look at availability now, walk through the availability sequence. Now again, I have the same cache service. The only thing that additionally added is I added this box called replication agent now. What that does is that does some handshake about how to really send the request to the secondaries and then all of those things. So that's why replication agent is there. So let's look at the sequence. These are all same as that. It goes to the primary, and then now it puts the request actually locally. It puts into the queue, as well as actually it applies locally. So it creates actually that object, and then it actually propagates operations to the secondaries. Now I introduce the notion of secondaries. So as part of the config option, you can actually pick for every named cache how many secondaries you want. You don't need to specify where and which ones. All you need to specify is I want actually 2 secondaries for this named cache. That means we actually will try to replicate the copy secondaries in 2 places. So that's an option that, depending on how much reliability and then availability that you need, you can pick anything from 1 secondary to n number of secondaries. So in this case, there are 2 secondaries, and so it actually queues it here, and then sends the request back to all of both the secondaries. Look, I'm doing it synchronously here. I didn't really return the control back. I sent actually the operation to the other secondaries, and one of them replied back. The other one didn't reply back, but it is okay because we are actually using a quorum-based protocol. So if you have actually 2 secondaries, majority of them replied saying that I got it. Even the other guy didn't get it, it's okay because I can still recover the data in case if primary fails. So in this case, one of them responded back, it returns back. Now a get comes, and then it appropriately routes it to the primary. It reads it. Now actually a request, the response came back. It doesn't matter when it came back. So the point only I wanted to make it here is you don't need to really wait for all of the secondaries to really acknowledge back. As long as the majority of them respond, that is fine. Now let's look at actually what happens in case of failure. Well, I introduced actually a few more components now. I brought something called partition manager, global partition map, so all of those things. And then there is something called reconfiguration agent. So let me go through what those things are. We talked about what a global partition map is. That knows about all the partitions that are in the cluster. And there is a partition manager which actually manages that. At any point in time, partition manager lives on one of the velocity nodes. It doesn't matter which one. One of the velocity nodes, it runs. And in fact, it can the partition map itself can actually be duplicated again on multiple velocity nodes for failover. What happens if the partition manager fails? We need to really have some way to reliably actually maintain the global partition maps. So it works like any other cache item. Or we have actually another ways to really support availability, and I'll get to that. And so in this case, let's say this node failed. And what happens? The neighbor notices saying that, hey, this node has failed. And then it tells the partition manager saying that, cache 2 has failed, do something, because cache 2 was the primary for actually K2, V2, we need to do something. And then partition manager actually looks at its partition map and then says, who are all the secondaries for this item? And then let me actually designate one of the guys actually as the next primary now. So in this case, it says, hey, cache 1 is the, it could be cache 1 or cache 3. Both of them have copies of the data. And then it picked actually cache 1 as the, next primary, sends messages to all the secondaries saying that, hey, now from now on, cache 1 is the primary. And then it updates that information into the local, the partition map. Now, we don't know actually how far the data items are up to date. Because we support actually quorum-based, the protocols, it is possible that, cache 1 may not have up-to-date data. In fact, cache 3 might have up-to-date data. It's possible. So cache 1 actually now sends to all the secondaries polling messages saying that, tell me, how far are you, ahead. And then it figures out saying that who has the up-to-date, most up-to-date, the data copy. In this case, for simplicity, I said cache 1 actually has the most up-to-date data. If it didn't, actually it gives up the primary ownership, says, you have it, you become the primary. Yeah. But in this case, actually cache 1 has the most up-to-date data. And then it says, I'm the primary now. It was already designated as primary, it doesn't have to do anything. Yeah. Then basically it initiates reconfig. Now it brings the K2, V2, which used to be a secondary, it became actually a primary copy now. So now the configuration is now, you have K2, V2, in cache 1, that's the primary. Cache 1 is now primary for both K1, V1, as well as K2, V2. And then, the secondary for K2, V2 is cache 3. So that sort of really shows the failover flow. So let's look at actually another configuration, which, is we call it an embedded cache. This is an interesting one where often people ask saying that, hey, why isn't actually, the cache, can it be part of my, ASP.NET application itself? And so basically in this scenario, both the client and the server components run as part of the application process. This is different from local cache. Local cache is, you still actually have a cache service. In this case, the cache services are part of actually your app. There are some benefits, but there are also some tricky, issues, with this. It does avoid serialization and network costs in this scenario. It provides, high performance, low latency, but guaranteeing locality and load balancing is tricky. Because because it's a cache service and I'm an application, I put this object, it could go to any of the boxes. Now, if I put the cache service local to my application, if I put an object, I would like it to be there. If it went somewhere else, then I might as well could have actually used actually cache service itself. So locating actually putting the data where it becomes really tricky. These things are really good for replicated caches, because the data lives everywhere. In which case, actually, it doesn't matter actually where you're putting it because it's going to all the nodes. But the fact that the whole cache itself is very close to your application, it's very fast. So in some configurations, the embedded cache is very useful. But the cache service is more general purpose use in all the scenarios that I've talked about. So we talked about the cache event notification. So let me just quickly walk through the flow of those things. What happens. So you have an application, and application wants to register a notification for key A and B. It says, whenever any item, data item with A and B changes, notify me. And in general, the notification mechanism, it's well known that there are two different kinds of notifications. Either you can do pull notifications, where you actually register your notifications, and whenever the data item changes, you periodically poll to find out, hey, has that changed? The other notification is a push notification where when the data item changes, it actually pushes it. And if it is a pull notification, then you keep very minimal state actually on the server because clients are doing more work. Because clients periodically go in and say, oh, has anything changed since this sequence number that I have? Just tell me. And if something changed, just give it back to me. If it is push notification, then the server has to keep more state. It needs to know who has all the up-to-date data, who has to what extent, and then send it. So it's much more heavy lifting. So there's much more work actually on the server side, and it could actually cause performance degradations actually on the server side. But if they're very, very infrequent notifications, then push notifications may be okay. So we actually, what we have implemented in Velocity are the pull notifications, where a lot of times, so you're doing your UI things, and in your ASP.NET application or something, you want to be notified whenever a cache item change, notify me. In which case, and then it's very chatty. It could be the frequently, updates are happening. In which case, doing it actually from the client side as pull notifications is much more scalable. So that's what we have done here. So the routing table maps the partition keys as usual. It knows that oh, these keys actually live on these two nodes. Now, periodically actually the client actually polls saying that I've seen till LSN 1001. If anything bigger than that is there, just let me know. Return back. So that's what it does. Nodes actually return all the changes. So it's a very efficient way to really implement it. And I showed you the queue before, and that's what the queue is really. The replication queue is used for notifications also. So let's look at. So I've sort of really given you an overview of really, what is a replicated cache, how is the flow, and the partition caches, their flow. So I introduced this notion of there's a local, I need to store the keys, I need to store the objects, and then I need to do notifications. I have a queue, I have replication manager, and then I have a reconfiguration agent. I have all kinds of these terms that I used. Let's look at actually step back now architecturally. Let's flip it, pivot it the other way. Let's look at the component architecture now. So if we look at the component architecture, before actually we go into component architecture, these are the certain factors that we thought about a lot, so in designing the system itself. To me, the most fundamental thing of using cache is performance. So you need to give me good performance. Otherwise, why should I really cache it? When I say performance, you're talking about really sub-millisecond access. And it could be like performance of actually the CPU usage, or the memory, or the concurrency control, or network performance. You need to really control how much traffic is flowing on the network, or how many hops am I taking actually to really direct the request. All of those are factors that you need to consider in designing actually the system itself. And then in terms of the memory management, what is the overhead of actually per object? How much extra overhead that am I keeping when I store actually an object? How fragmented is your memory? What is the eviction algorithm that you use? What is the garbage collection overhead that I incur? All of those some of the factors that again go into the design. From the scale perspective, how well can I really load balance the data across multiple boxes? When MK showed actually the demos, every time actually a node went down, we worked to make sure that the load sort of really gets propagated evenly across actually the boxes. The more evenly that we can spread, the better actually we are utilizing actually the resources. And how can we do dynamic cluster management, dynamic load balancing? These are some of the factors again that drive the designs itself. From an availability perspective, data as well as the metadata. What if I have notifications? I don't want to lose my notifications. I subscribe to those things. Not just the pure data. All the other metadata also. I need to make sure that it's highly available. And then finally, consistency is an interesting one. Where there is whenever we actually build distributed decentralized systems, it's typically is at odds with consistency. If you want very strict consistency, then you are going to really give up some availability, or it could be some scale, or it could be performance, all of those things. But depending on your application requirement, you can actually relax it. For example, I'm actually building an app where I'm checking for my status of my order. I'm purchasing something and I wanted to check actually whether it has fulfilled or not. I go to Amazon and then check, hey, have they shipped my order? So what is the status of that? Guess what? If the status is actually 5 minutes late, it doesn't matter. It doesn't have to be immediate. In which case, that means your application can actually tolerate some staleness. And that's really nice because it allows my system to be a little bit more asynchronous now. So I don't need to really have most up-to-date data. So depending on actually your application, you can configure that. And my personal experience actually of looking at lots of apps is majority of the data, lots and lots of data can actually live with weaker forms of consistency. And again, we can actually eventually be consistent. So that's one of the things that in our designs, we really made sure that today the V1 system actually pushes more stronger consistencies, but we want to make sure as we move forward, we can actually relax it more and more. So that's another important thing to remember. So let's look at actually the components, and it's sort of really probably a very cluttered slide, but let's look at some of the the components. I will start with local components and distributed components. So the local components, one of the key things is the data manager. This is the data manager basically does all the memory-based local data management. This supports hash table access, and then B-tree access methods, and both support for record-oriented accesses as well as set-oriented. In V1 we don't have set-oriented accesses, but this is one of the things that we want to add in beyond V1. And provide support for tags, and then tag-based access, the concurrency control, versioning of the objects, as well as in the longer run we actually want to have somebody asked a question in the previous session. Hey, I have SQL Server in the backend. Can I actually map a portion of the SQL Server into some concept actually into the cache? Take portions of the SQL Server and then map it into as fragments in the cache. It could be a region or it could be something else, so that I can actually do some querying on those things. So the notion of really some schematized shape of the table schemas as well as fragments is something that the data manager will understand. So those are the things that data manager does. On top of the data manager, what we have is actually with an object manager. This is the one actually is providing the object abstraction. The object actually gets mapped into the local data manager and then gets stored, but the object abstraction is provided actually at this level. It provides actually it does things like notion of a region, what is an item, and then the cache policies, so when should I evict it, and then what is the sizes of the cache. All of those things are actually done by the object manager. On the top of the object manager, we have something called a distributed object manager. This is the one which actually figures out, which runs on top of the object manager. In case of simple routing, that means if the request came, if the routing table on the client, let's say, is not there or it's not up to date, then it hits some server, and then that server actually looks at the local partition map and then says first, oh, is it local? Oh, it is not local. Then it looks at actually the partition map, the global partition map, and then figures out where to send it. So some of the dispatching of the requests actually happen at the distributed object manager. It is the one actually talks to all the distributed components that I'm going to describe now. And then you have the API layer, the services layer, and then the bunch of distributed components. I'll spend a few slides actually on this now as we move forward. One of them is the cluster substrate. We'll get to that. And then all the availability substrate. So where you have the routing table, local partition maps, so replication agent, all of those things. And then finally we have a client layer, which talks about cache APIs. And I didn't mention the query part of it. Both the object manager as well as actually the client layers have some form of actually the query processor. The object manager primarily deals with local querying, whatever objects it has, the regions or a collection of objects. It will support the link queries on that. And in terms of the client layer, you do have a federated query processor where, given a query, it has to go across multiple of the cache node. Think of really like a map-reduce framework, where so that is what actually is supported by the client layer. And then you have the admin in the monitoring tools. That's sort of really the component structure that what we have built here. And let's look at actually a few other concepts actually in the DM. So now that I've introduced some of the things are very interesting, and then we did them for performance reasons. One of them is the optimistic version-based update. When really multiple applications and multiple threads are actually accessing the object, how do we really provide synchronization and concurrency between those two things? We support both pessimistic as well as actual optimistic. In case of optimistic concurrency control, let's look at the sequence of the operations. You have two clients, and both of them are actually getting an object called Zune from the player region. Both of them got that. And they can actually get the cache item. Along with that, what they get is an item version number. So they have that version number also with them. So let's say in their application, they've changed actually the inventory. Both of them actually decremented the inventory. Now, both of them actually write it. Let's say, the cache 2 thing gets in first, but it actually supplied actually the item version number also. What that means is the DM actually looks at saying that, hey, has that version number changed, since, whoever read it? If it has not changed, because whatever is supplied by the client is compared with actually the up-to-date version number. If there is no change, then the update is allowed, the put succeed. However, the second one comes and then gives the version number, it doesn't match because both of them, client 1 and client 2 read, it was, let's say, version number V1, but already client 2 has increased to V2, so there is a mismatch, and then the client has to retry it. There is a disadvantage here that client actually has to retry it. However, there's a huge performance gain here. We didn't take any locks. There's no synchronization, so there's really none of those overhead. So again, the performance, this is where by default, this is the operation mode that we operate on. We do supply actually pessimistic locking where you do want to really lock things. Let's say I have a folder, I have a K1 item. It could be some item, and then client 1 and then says get it and then actually put a lock on it. So this is a pessimistic concurrency control where now you got the read it, but put a lock. Now what that means is now somebody else comes and then get an lock and then they fail because other client cannot take the lock. However, somebody can just read it. They didn't take a lock, they just read it because reads never block in our system, so they can always read actually version of it. But if you try to put it, there's a semantics for what's the semantics of actually the put itself. So on the get and lock, get the object and then takes a lock, and regular gets do not block, but regular puts actually overwrite it. But we have something that actually put and unlock it. If somebody actually has it, if you put and unlock it, then it basically puts the new object and then unlocks it. If you are the one who have taken it, a lock, and then you put it back, then you succeed and unlock it. But if you're not the one, then you never had a lock handle, so put and unlock will fail. So the normal recommendation is to really use get and unlock and then put and unlock primitives if you're using actually concurrent pessimistic concurrency control. And the other thing that important thing that that I want to mention in the components is there were several questions actually in the last session about hey, what is your eviction policy? How does this work? I keep putting object into the cache. What happens if I run out of memory? So how do you deal with that? So we have support actually. We provide several ways of really dealing with the the memory pressure. One of them is there is an expiration that you can specify actually an object. That means whenever the expiration times out, then they are actually potential candidates for eviction. So periodically, the eviction mechanism wakes up and then says, are there any expired items? If there are expired items, I'll throw them away, so that it makes actually room, memory space available. This hard eviction is where, well, I really need actually data, some space. I need to put it, and there is no space right now available. It uses the traditional LRU scheme to really evict, certain candidates. And then finally, we also built a memory pressure-based eviction where it looks at actually overall system memory pressure, and if it's really beyond 85% of utilization, the memory usage, then it's actually kicks off the eviction, and it uses either the expiration mechanism or hard mechanisms to really make some space. It actually makes about 5% of space, extra space. And we can also register callbacks when things are evicted so that you can do something at that time. So these are some of the things that we built for memory management. And in terms of really describing the component, another important aspect is the whole cache event notification. I sort of really talked about this already. There is a queue of all the operations, and then there is a logical sequence number, and then every client actually knows what it has seen, the last known LSN. And then whenever it actually polls, it actually sends that, and then that is actually compared against the current LSN. If If it's obsolete, if it's basically if it's less, then it sends out the the data to the client side. And finally, talking about persistence, is we are looking at actually providing callbacks for read through and then write behinds. Remember, I didn't say write through. We looked at write throughs and then we sort of deferred it for now, because if you did a write through, then what that means is it's in the path of actually if you put. So whenever you put, and then you need to really write through to your backend data store, then you're incurring the overhead of really, until that operation is finished, writing persistently to the backend store, your control is not returned to actually the application. So the latency wise, you need to really include the latency of writing to the disk also. Whereas write behinds, it actually does the puts very efficiently, but periodically it wakes up and then actually pushes data actually into the the backend store. And we think actually it's a good way to really dealing with persistence, because you can still have availability, because you have multiple copies of the data, so you can use that mechanism to really make sure that your data is not lost. And then asynchronously you can push actually the data actually to the backend data stores. So what we plan to do is provide both write through and then the write behind and then read throughs, and this you can specify it actually the callbacks at the named cache level. It's not a default. By default we do this. It's something that you explicitly ask for it. And the distributed component, this is an eyesore, but it's actually, think of it's the same node. The thing that I wanted to point out was that all the nodes are the same. In fact, some of them show actually more boxes, but really the code, the software that is there is the same actually on all the boxes. The only reason that I showed the partition managers and then two of them is, it is actually a way to replicate the partition manager so that if one fails, then other can take over. And I also showed actually a GPM external store in case that's another option is, what, I'm actually going to keep the partition map somewhere else. So if something fails, I can always get it from actually some persistent store. We actually allow you to put that in SQL, and you can read it from there. But otherwise, the components are very similar. The key concepts here are basically, I have 3 slides next that I'll cover that. How do I manage my cluster? How do I deal with actually the partition maps? And how do I reconfigure my system and then in case of failures? Those are the 3 things that I have covered. And this is a slide that actually another important thing that I forgot to mention is the distributed components. All of the let me see. Yeah, the components here, the partition manager, load balancer, replication agent, reconfigure, all of those things are jointly shared by SQL Server Data Services. If you look at SQL Server Data Services, is again building a very large scale service. It's a distributed system where there's multiple SQL Server systems are running on some distributed fabric. And in this case, actually, Velocity is running on the distributed fabric. So we do share actually the common components, the cluster management, the primaries, the secondaries, the replication, all of that stuff is shared between those. We both share the same code. And that's the reason why I'm saying that is there is a more detailed talk on Thursday. It's the BB03 session number where Gopal is going to more details. Primarily is focusing on how does the the cluster management happen, how does the very large scale geoclusters work, so how does the routing work, so he's going to really go into more details. If people who want more depth, so I highly encourage them to go to that. But fundamentally, the way the clusters are managed is, think of really you have a ring and all your cluster nodes are configured in a ring, and every node is watched by some neighbors. In this case, the example is, you have the node 64, and then the immediate neighbors are, is 76 and 50. But there is a notion of actually neighborhood, which is much larger. Think of this as sort of really, you go to sort of the exponential distance and then go to, reach everybody, in the ring. So in this case, the bigger neighborhood includes all the LO arcs. What that means is, in order for you to route a request, let's say, I need to send, request from 64, to, I'm sending it to basically, in this case, to 120. The way it happens is it knows, you cannot really maintain, connections to every possible node, in the cluster, in which case it becomes almost, very difficult actually. Your connection overhead is so much, then it's not scalable, especially in a large scale cluster. So in this case, 64 says that, so the nearest is actually 135, so I'll send it to 135. And when that 135 has actually, it's, one of the neighbors is so 103, and then from there actually it sends it to the immediate neighbor, 120. So it's basically think of really it's like a binary search. So that's how, you're sending it to your target node. That's how the communication happens. This is all actually done by the cluster, the distributed fabric, that SQL Server Data Services provides. In addition to that, it also has mechanisms built to detect network partitions. What happens, if a network has partition, then it actually detects it so that, we never really become inconsistent. There are, the people argue about, hey, should you actually relax the consistency in those cases and allow availability? That is something that, we will look in the future. But right now, the mechanism makes sure that in case of network partitions, you never actually make data inconsistent. Again, go to Gopal's talk. And the other component is the replication agent. What it does is it's for high availability. It is a basically single master based, primary secondary based, mechanism. There are mechanisms which are, more multi-mastered based systems, which we will explore it in the future. But currently, we have a single master. As I mentioned, every data item is mastered by a primary. It's based on that, the availability. And all the write operations are always sent to the primary, and primary propagates the operations to, the quorum of the secondaries. And there is an operation queue that we talked about, which is used for replication and reconfiguration and then notification and all of those things. So that's something that, that component does. And then finally, the partition manager, I talked about it, it's really the range of the hash values of the keys, and then partition maps partitions to nodes. And the global partition map has the view of all the partitions in the whole cluster that includes all the named caches. And the local partition map is only local to that particular node. That's the local partition map. And there's the partition manager, which actually maintains all of this information. Again, there is one partition manager, always, and it is the one. In the cluster, there's only one at any time. But there could be replication so that if it fails, so you could fail over to those things. Yeah. And we went through that sequence, so I don't want to, spend time on this. And finally, reconfiguration agent is, I showed that slide when, in the availability slide, when cache 1 became a primary, it was selected as the primary. It used to be secondary, it became the primary. It does something called reconfiguration. What it does is at that time is, it tries to really become a primary. In the process, it needs to notify everybody. Maybe it needs to bring actually a few more secondaries, all of those things. That's what actually called reconfiguration. And the component which does that is called the reconfiguration agent. Basically, primary failure kicks that off. And then sometimes, you may really switch to a new primary. You may want to take a primary offline for whatever maintenance purposes, so you want to really add a new upgrade or whatever it is. Then, you kick off this reconfiguration, and then it picks somebody else actually as the primary. And there could be secondaries failed, and then, so you may want to remove it, or you may want to add actually new secondary. MK showed in the demo that, we added actually the new secondaries, and that's another scenario. And partition manager elects the new primary, and then, it needs a reconfiguration. We talked about that. So that's sort of really the components that are in the system right now, and some of the scenarios and then some of the flows, the operational flows, I described. Now let's look at actually some of the things that we are thinking about. MK actually again talked about only the V1 the roadmap, but these are some of the broader thinking about where we are going in the future. One of them is actually executing link queries. So where there's objects actually in the cluster, and Velocity Client, you actually request a query. Let's say the query that you want to run is you want to really, there is a named cache called catalog, and you want to really find all the toys where the toy price is bigger than 300, and that request actually is sent actually to all the nodes, because the data actually is partitioned across all the nodes. So the same query actually goes to all the nodes, and then we collect actually the results back, and then return the results. And this is the simplest form of really showing some kind of a map reduce here. You can actually build more and more sophistication, but it's a simple form. And we don't need to really do this. We don't need to send it to all the caches all the time. Suppose if your query is actually based on primarily on one region, in that case, you can only go to that specific region. What region guarantees all the data belonging to that region is co-located physically. So in this case, you want to go toy region and then run the same query, give me all the toys from the toy region where the price is greater than 300. And then the toy region actually happens to be on cache 1. So in that case, you send the request only to that node and then get the results back. So I don't know if there is time, then MK can show a demo, but we'll see. I think I have till 4:45, right? Yeah. The other thing that we are looking at is HPC integration. This is again somebody asked about so what about computation? How do you scale computation? This is something actually is already prototyped with the HPC job framework, where the things that are at the bottom, there's a job, the workflow where HPC is doing some computations on the financial data. But right now, before the prototype, they were getting the data all the way from there's some reference data that they need to get it from. This is the tick data from central market data store. What we have done is actually we put that into the cache, and the HPC, the job, the flow actually now reads the market data from the velocity data cache. That has significantly improved the performance. However, this still does not really do as much as I would like. I really would like to really co-locate the computation close to the calculation operation itself. So what I really would like to do is to push this down here. So what that means is I want to really have the calculation operation co-located with the velocity node, velocity data. So these are very similar to what you typically do with your stored procs. So where you have your stored procs, and then you have data close to it, and so you actually have the functions are actually shipped closer to the data. So that's what we would do. This is not done, but this is something that we are working with actually HPC guys to really make this, enable this, the job framework stuff. Some other futures is velocity in the cloud. Is what are our thinking on the cloud? Again, we are working with the Azure team and then SSDS. There's 3 scenarios that we think that those are possible. One of them is application hosted in the cloud itself. This is already, ASP.NET application can be put in the cloud, and where does the cache live? The other one is, my application is on-premise, but I want to access actually Azure service. And then finally, Velocity as a cache service itself. So here are, so this is a configuration where everything is in the cloud. So we will actually put, the Velocity cache working on, the Azure. And these are the Azure service roles. These are the applications that everything is running in the cloud. The other configuration is where the cache and then the application is on-premises, and then the data, the service itself is in the cloud. The third possibility is really, can we provide cache actually as a service? So that's another thing that we are looking at. So these are some of the futures that we are looking at. And I have a few demos. I think I have 10 minutes of time, so I will actually have MK come back and then show you a link demo, and then as well as the notifications demo. Then we'll take a Q&A.
Hi. For those on the video, I think he kept talking about MK's talk. That's TL14, which is a previous talk that we gave about Project Velocity, a first look. I'm just going to quickly show you a notifications demo and a link demo. Let me jump here. So we have like a private build that we got with the notifications enabled. And I'm just going to log into the system here. So as he was explaining earlier, so what I've done here is a simple forms-based application. It decided to log me into the other user role. Just give me a second. So what I've done here is a simple Windows form-based application. I had loaded four different Windows forms, and what I'm going to show you is how if I kind of insert data from one of the form and delete data from the other form, the rest of the other forms can actually get the notification and show you the fact that you are getting notifications. Takes a while for it to come up.
It's not using the cache.
It's actually going across the wire to the data center, and I guess since we hadn't touched it in a while, so it decided to log me out. And actually, this turns out to be the link demo. Maybe I'll do the link demo first. All right, so let me just make sure the cache host is actually available. So the cache host is down, so let's start the cache cluster. So this was the other part. So what we have is we have the partial admin tool integrated with Velocity, so you can use the partial commands to actually start and stop Velocity instances. In this example, I've installed Velocity on one of the machines, like this 13 machine, and I'm going to just start the cache cluster, so it just starts this instance alone here. So it just takes a second. And actually, you can use this partial to actually start the whole cluster as well. You don't have to just start one machine. You can actually start, if you have a 100-node cluster, you can go to just one of the machines, use the partial to kind of start the whole cluster. So let me quickly, briefly explain what demo I'm going to show first. I guess this is a link demo. So we have a toy, and I have the toy name and toy price. And I also have, this is the simple API that we have for Velocity, which is we first get the cache factory, and then we get the cache from the cache factory. So as Anil explained before, the cache factory kind of gives you the instance, the connection to the caches, and then you can specifically ask for which name cache that you want from there. And then you can go ahead and create regions within that cache. In this example, we're creating the toy region, and I'm going to put a bunch of objects into the toy region. And now you can actually run link queries on that toy region. So because we don't have full link support within the cache, I have to simulate this example, but you can kind of think about how it will look. So you should be able to say from C in cache.getEnumerator of toy. So here I've made enumerator like a function, but you can say cache.getEnumerator once we support all of link. And here, what I'm saying here, I'm looking for cache, and then I'm looking within toy region, I'm trying to get all the toy entries, casting them into the toy instance, and then ordering by the toy price and returning that. Right? And then and then I'm going to print the results of that. And following that, I can also do operations like where c.toy price greater than 300 and look at that as well. Now, furthermore, it's not just region level. You can also go to the cache level and look at the whole cache. So you can, for example, I'm just going to put all the toys within the cache, and then I'm going to get an enumerator of the overall cache and do the same operations. So if you think about a partitioned cache, given a link query, we can now distribute it across the cache and get the results. Again, but this is a simulation run, so it's not actually pushing it to the cache service, but you can kind of think about or conceptualize how it will work. Just quickly run it. It's running here. So first, it's trying to connect to the cache here. It'll insert all the objects. And as you can see, first, it picked up all the toys in the region. That was the first link query that we did. And now it's now selecting all the toys with price greater than 300. So this is still going to that specific region and getting it. And then this next enumerator is kind of getting all the toys in the whole cache. This is like 2,000 of those entries. And then the final result is just the toys greater than 300. So it's not just, you don't have to just put the cache and just get it by key. You can now, you could potentially use link as well to kind of get, filter the objects that you have in the cache.
Yeah. I think that the idea here is to really give you a sense of really the kind of data services that you can get. Query is one of the services. Over time, you think that more and more services will be enabled on that. It's no different from actually how you'll actually access the database systems. So you'll do more and more capabilities in the cache tier itself.
So go ahead while I load up the notification tab. It seems to have disappeared on me. So.
Yeah. So one of the things that when he said simulation, what we have not done really is we don't really have a federated query processor yet, because it's not in. This is beyond V1. We want to really make it clear. So it's not in V1. So what we really have done here is that pull the data and then we showed the results. Here the emphasis was more on what the capability that we can provide rather than the mechanism that we built. But what we really want to do is to really send the fragments of the link query, the link expressions, to all the nodes, and then perform the operation there, and then send the results back.
Okay, so I found my notifications demos up here. So here's going to be 4 forms that's starting up. This is plain old Windows forms, and I decided to throw some exceptions, I guess, because I didn't restart the cache cluster.
Okay, maybe we should.
I should just restart the cache cluster. Hold on. This is what happens if you leave the machine too long. So the restart cache cluster is another option. Again, you can go just stop and start services as you like. And once it starts again, let me just start it. So these are things that we just put together pretty recently with the latest bits. So while it's starting up, let me show you what the demo actually does. So I have 4 forms here, and each one of the forms I'm actually going in and registering notifications with the server. So if you look at form 1, this is the form where it's going to subscribe for region level events. And if you look at actual code within the form itself, I just have this simple registration. So I do the same get cache thing, and I'm looking for register event. And then I'm saying, okay, now register for all events, replace or remove on the toy region. And similarly, each of the other forms, I have different registration. One of the forms I'll register at the key level, the other at the cache level. So now the service is up. Let me just run this again. Hopefully it wouldn't throw exceptions this time. Takes a while for it to come up. There you go. So here you go. And this is my entry form that I'm going to just enter some of the values. And this form is listening for cache level events. So all the events that are going to happen in the cache, this is listening on. This form is just listening for region level events. And this form is actually listening for key level events. What I have subscribed in this form, that same API that registered notification, I'm looking for anything with item 1, item 2, all through the cache, or any key within this, any key called toy 101 within this region. So if I go here, I'm just going to add I'm going to add toy 101 within this region. And let me just create the object. So I have just a create entry button. All that is doing is just calling that simple put API. And immediately you see that at the key level events, that got registered because this guy was looking for toy region toy 101. Cache level also it found it. And the region level also it found it because this is subscribed to the whole region. So now let me do something, maybe item 1, right? Item 1, where I don't have any region, I just have the key called item 1, and I enter a value, item val, and I'm just going to create the entry. As you can imagine, it should come up in these 2 boxes because this guy has subscribed for item 1. You saw item 1 appear here. And this cache level events also has subscribed to it, but obviously you don't see it here because this is subscribed only to the toy region. So you can imagine I can just play around with it, like show you different items where if I can even delete this toy region, for example. I can delete this row, and you will also get the remove event. Yeah. So you can kind of imagine how you can use notifications to do various activities like archiving, logging, or just figuring out what's happening in your cache.
Well, let's, both of us are here, so you just say, and then if you have any Q&A, so feel free, and we'll hang around also.
Thanks.
Thank you.
Do you foresee anybody using this for IPC or other purposes now that you're basically providing efficient pipe between interconnected processes?
Actually, yes. I'll answer that question. We are actually talking to a lot of internal groups like Xbox and others who are looking at it to see if they can use it for things like presence and other kind of activities with notification.
I was curious with the, sorry about that, the link queries, it seemed like the servers would have to know about the domain objects.
Yes and no. Yes
yeah.
and no. It's a very good question, right? It depends on the kind of queries that you want to do. One way is, at least our thought process is, you should be able to link on, say, tags and name value pairs and other properties outside the object as well as things within the object. Obviously, if you want to query within the object, we would need to have access to those domain classes.
So one of the things that I didn't mention is that, as part of this effort, we are actually working on building actually an in-memory query processor. So the representation of it, we will actually manage the memory efficiently, whatever is necessary. From that perspective, yes, I do need to know what the shape of these objects are, but you're not really using the IEnumerable link evaluation. We can actually do more iQueryable evaluations because we have our own in-memory query processor and database actually.
Okay. I was also curious, is it possible to do a combination of the federated and replicated?
Partition and replicated.
Partitioned and replicated, yes.
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 Okay.
In fact, we're looking at it sort of like a weak replicated model where if you open up the secondaries for reads and writes, or rather reads at least, you get that partial scale, for example, right? Where you have partitions with secondaries, and then all of them are available for read. Now, writes, it's still a tricky thing. If you want to go to anyone, then consolidation, all that thing. I mean, how do you reconcile the versions? That becomes a tricky issue. But yeah, we're looking certainly to open it for reads.
Thank you.
Does Velocity provide the native C++ API? And if not, do you plan to provide some?
Yeah, the native APIs. Yeah.
Yeah.
It's not,
So not in V1. We
but
were
post
initially
V1
planning, but
definitely.
it doesn't look like we'll make it for V1. So, but post V1, we have a lot of interest in PHP, C++, and Java. Those three seem to be major on our list. So we are seriously considering that.
I mean, internally, this is one of the big asks from IIS guys is C++ APIs. Yeah.
And the other option also is most like we would be publishing all the protocols and everything anyway as part of our open initiative, so anybody can come write clients as well. So you don't have to wait for us to provide.
Thank you.
It's in addition to the link question the guy just asked. So when you call a link query, is it going to return the whole data set to the client and then perform the filter there?
No. The demo, yes, that was the case because we didn't have it. But when we do it in V2, our idea is to be able to push the link to the service. In fact, it's federated, right? Because the data is partitioned. You want to push it to all the nodes, do the queries there locally, and then get the results back, aggregated in the client.
Okay, and the second one on the get and lock, it said if someone held a lock, it would fail a second request.
That's right. Any other get and lock would immediately fail. It won't hang.
So is there going to be any support to say at least give it 100 milliseconds before?
Yeah, there are expirations. There are lock expirations, definitely. So
No. I think his question was, do you want the get to wait
Yes,
to get the
like
lock
a
before
get
it?
and block.
Oh, get and block. Okay. So the other options we were thinking of is maybe to give you a notification back once the lock is available. But yeah, that's something we'll definitely look at.
Yeah.
So like sort of get and lock, but with some time, right? Wait, like do a tight loop.
Yeah,
kind
like
of
the
thing.
read or
Reverse
write
lock
or
for
lock
like-
when
yeah.
you require those. Okay.
Yeah. Okay. We'll look at that. Thanks. Any other questions? Oh, there.
Oh, there's one question.
Oh, the mic's off.
Yeah. On the distributed query, how would you deal with grouping? So sorting or anything, you'd need to have the client as well apply something or break apart the link or cripple it.
That is right.
Yeah, so we should take actually the distributed query separately because we have a lot of thinking, a lot of thoughts on how we do it because it's post V1. But actually, I can have a chat with you. So how we plan to do that. So yeah.
Go ahead.
Yeah, the question is, what do you use for the communication?
We use WCF today.
WCF?
Yes.
And what's behind? TCP or?
Yeah,
TCP.
TCP. Yeah, TCP underneath.
Yeah.
So we are looking to see if we can even do raw TCP, but WCF seems to be pretty well, whatever. Performance-wise, we're pretty happy with it for the most part.
Everything behind is TCP?
Everything
Notifications?
internally is TCP. That's correct.
Yeah,
That is
thank you.
correct. Sure. Any other questions?
Yeah.
That's it.
Thank you.
Thank you.